Assignment 5. We're going to cover 3 sections, all review, and all having to do with linear equations and inequalities. How do you graph linear equations and inequalities? And how do you write equations of lines? So in the past, you have learned about 3 different types of equations of a line. They all mean the exact same thing, okay? Let's start with the middle one here, slope-intercept form. You all know what this one is. I know that for a fact. M is going to be our slope, and B is going to be our y-intercept. And remember, your y-intercept is a point that's on the graph where your x value is 0, but you have some y value, okay? All right, in addition to that, you've probably seen standard form at some time in your life where, you can then get x and y on the same side. And this one is really good to use for finding x and y intercepts. So this is good to use to find x and y intercepts. Okay, so this one's really good if you want to graph using your x and y intercepts. And then the first one is the point-slope form. So this is where you were given your slope, or maybe you found your slope, and you have a point, okay? So this is where basically x1, y1 is a point that you've been given. And so this one is really good if you are given a point and a slope and you want to come up with the equation of a line. So I'm going to use each and every single one of these as we go through our examples. So starting with example 1, graphing lines. So we need to graph the function f of x equals 5x minus 5 halves. So let's think about which form this is in. Okay, so another way of thinking of f of x is your output, which is your y value, right? So I could also think of this as y equals 5x minus 5 halves. Okay? Well, which form is this in? So to me, this looks like it's in slope-intercept form. And right away, I can identify what's my slope, what's my y-intercept. So my slope is 5, and my y-intercept here is negative 5 halves, which means that I have the point 0, and I'll make that into a mixed number so it's a little bit easier for me to understand and to graph. 0, negative 2.5 is a point on this graph. Okay, so the function was f of x. I know that my inputs are x, so I'm going to label this axis as x, and this axis will be f of x. Okay? All right, so starting with my y-intercept, I'm going to start at negative 2.5, so that's about here. If this is negative 1, negative 2, this is negative 2.5. And from there, I'm going to use my slope to find another point. So my slope is 5, or 5 over 1. So I take my y-intercept, and now I need to go up 5 spaces and over 1, rise over 1. So 1, 2, 3, 4, 5 puts me here. Oh, I don't want to do that. What is that? That's 1. So it brings me up to 2.5, and then I need to go over 1. So there's my point right there. All right, and I'll mark that as 3. So I end up with a really nice line that I can create because 2 points make a line. Maybe a little too far. Got excited with my ruler there. Okay, so that's my graph. Pretty simple, pretty quick. All right, so now I've been given an equation in a different form. Now, that's fine. You can turn this into slope-intercept form. if you want. You can do that all day long. But sometimes when you're given an equation in the standard form, it's a little bit easier to just find the x and y intercepts. So that's what I'm going to do to graph this, and it's really important that you understand what an x-intercept is and what a y-intercept is. Okay, so let's think about that. So let me just come over here and draw a little side graph. Here's my x-axis, here's my y-axis, and here's a graph. This is some function. Sure, we'll call it f of x. Why not? All right, so my y-intercept is what crosses the y-axis. And as we said, it's usually going to have a 0 for an x and some y value. And then my x-intercept is what crosses the x-axis. Now, it's always going to have an x value, but 0 for the y value. All right, so this here is known as the y-intercept. And this value here is known as the x-intercept because they intercept those axes. So when I graph using my intercepts, it's really easy to just make an input-output table. And I can say, well, when I want to find my x-intercept, what's going to be 0? So for my x-intercept, I know that y is 0. Which means I can take my equation, I'll plug 0 in for y, I'll figure out what x is, and that's going to be my x-intercept. So let me go ahead and do that. So this term becomes 0. I'm left with 3x equals 2, or in other words, x equals 2/3. So I know that one of my points is 2/3 0, or that's my x-intercept. For my y-intercept, I'll do the same thing. Now, on my y-intercept, what's 0? My x's, right? So I can plug 0 in for x, and then I'll figure out what my y-intercept is from there. So same thing, I'm going to plug 0 in for x. So I get 0.2y equals 2. Divide both sides by 0.2. So y equals 10. So now I have my 2 points, my x and my y-intercept. And I'll just go ahead and plot those. So this is my x-axis. This will be my y-axis. Let's see. So for my x-intercept, I'm going to about 2/3, which is approximately here before I get to 1. 2/3 of the way to 1. And then for my y-intercept, well, it looks like I'm going to need to 2, 4, 6, 8, 10. Why don't I go up by 2s? 2, 4, 6, 8, 10. So it looks like I'm right there. And my graph is going to look something like that. On to example 2. Now we're going to kind of reverse this. We're going to be given information and we want to write equations of the lines. Okay, so I've provided you with graphs here, but you actually don't need that. I'm not sure why I did that. I apologize. They've already been printed, so this is what you're getting. So let's start with the fact that I know the y-intercept and I know the x-intercept. Okay, so I know 2 points of this equation, and so I should be able to now come up with the equation of a line. So you probably want to keep referencing back to the different types of equations of lines. Okay, now if I know my slope and my y-intercept, I jump right into this equation. Okay. If I know maybe my slope and a point that's on my line, I would use this equation. This equation is a way to just say, hey, everything's in standard form. X and Y are on the same side. Okay, so it's not very useful for creating equations. These are the two that you would usually use to create equations. This is more useful for putting it in standard form, having like one set form that you always keep your equations in. It's also really, really useful for finding your x and y intercepts. Okay, so for me, I have 2 points. With those 2 points, I can find a slope. So I'm going to go ahead and find my slope, and I'll use one of these 2 equations. So let's start with finding our slope. All right, so we know that to find the slope, you want y2 minus y1 over x2 minus x1. Okay, I'll call this x1, y1, and I'll call this x2, y2. So my slope will be 0 minus negative 2 over 1 minus 0. So that becomes positive 2 over 1. So my slope is 2. Okay, so I know right away that my equation can look like this, 2x plus b. So I guess the next question is, do I just have another point, or do I actually have something that I could use for slope-intercept form? So going back to slope-intercept form, do I know my y-intercept? And as a matter of fact, I do. The way it was given to me, I was actually given my y-intercept. So I know that this value right here, negative 2, is my b. So my equation then is y equals 2x minus 2. You can graph it if you want. I don't know why I put those there. I made these on a Friday night and I was excited to go home. All right, so the next one. The line through negative 3, 4 with a slope of 2/3. So let's go back and look at the equations that I have. So if I know my slope and my y-intercept, I can use y equals mx plus b. But I wasn't given my y-intercept this time. But I was given just some random point where that's like this x1, y1. Okay, so that's the equation I'm going to use as my point-slope form. All right, so point-slope form, I'll rewrite it for you here. It's basically your standard y minus y1 that comes from your point equals your slope times your x, that's standard in your equation, minus x1, and that comes from your point. Okay, so I have been given my slope, and I've also been given a point. This will be my x1, y1. So I just basically, I plug it into here. I do y minus y1 is 4 equals my slope, which is 2/3, times, and then x, which is part of the equation, minus the x1 of my equation, which is negative 3. Okay, so this could be y minus 4 equals 2/3 times x plus 3. Now the problem's going to be when you look in the back of the book. So you look in the back of the book, the answer might not look like this. The answer might be in standard form. So if that's the case, you need to be able to manipulate this. So let me show you real quick how to just put this in standard form where you have x and y on one side of the equation. Okay, if I don't specify though, this would be an okay equation. Or if the book doesn't specify. But sometimes you're going to want to move things around just to double check your work. So going from this, the first thing I would do is I would distribute that 2/3. Now 2/3 times 3, well that's just 2. Okay? And so now for standard form, if you look back at that, you have x and y on the same side of the equation, and you have your constant on the other side. So I want x and y on one side of the equation. Okay? So I need to bring x over here, or y over here, one or the other, and then get my constants on one side. So I think I'll bring 2/3 over here, so I'll subtract 2/3 x from both sides. And I'll also add 4 to both sides. So I end up with negative 2/3 x plus y equals 6. Now there's only one more problem with what I have going on here. When it's in standard form, you basically want integer coefficients, okay? And you want your first one to be positive. So you want the coefficient of x to be positive, and you want them to be integer, meaning they're like whole numbers. They can be positive or negative, but they're whole numbers. So what I'm going to do is I'm going to multiply both sides here by something that would clear this fraction and make the coefficient of x positive. So I'm going to multiply both sides by -3. So that when I do that, if I distribute my -3 here, I end up with a positive 2x, distribute my -3 here, and I end up with a -3y, and then I also needed to multiply the other side. That would give me -18. So these two equations are the same. The problem is when you look in the back of your book, you're probably not going to see this one, but you're going to see this one. Okay, so if your equations are given to you in standard form, and they're telling you to give it in standard form with integer coefficients, then you need to be able to manipulate it and turn it into something in standard form. Okay? Next one. Let's see here. I've kind of gone over my allotment. That's okay. So I want the line through to -3, and I want it to be perpendicular to this equation. Okay, well, I know the slope here is 2, and perpendicular lines have what kind of slope? That's right, opposite reciprocal. So my perpendicular slope has to be opposite, which means it's negative, and it has to be the reciprocal, which means I flip it. Okay, so that's going to be my slope, and it's going through this point. So which form of equations do you think would be the best one to use, or the easiest at this point? And for me, it's, again, I have a point and I have a slope. So using the point-slope form is going to be probably the easiest just to get an equation. Maybe you really like slope-intercept form. Okay, great, you can do that, but you're always going to have to figure out what your b is. And that's okay too. All right, so I know that my slope that I'm going to use for this perpendicular line is -1/2. I also know that I have this point. We'll call that x1, y1. And I'll go ahead and I'll plug in y1, where I see y1 here. And x1, where I see x1 there. So this really becomes y plus 3 equals -1/2 x plus 1. Now, could I easily put this into slope-intercept form? How could I easily get y all by itself? Yeah, I could just subtract 3. So I'm manipulating these so you can see them and compare them no matter what form they're in. So this would actually be y equals -1/2 x minus 2. And this would be okay. This would be okay. Or you could put this into standard form like we did there. And again, it's going to be all about, well, how's the answer in the back of your book so that you can actually check your answers. All right, so, and I guess the important thing, which I'm just imagining you guys already know because we spent so much time on it, is that perpendicular lines have slopes that are opposite reciprocals. Okay, so if you don't know that, you might want to write yourself a note. Okay, slopes are opposite reciprocals for perpendicular lines. So for parallel lines, how are the slopes? What do we know about the slopes of parallel lines? Parallel lines have the same slope. So the slope here is 2, which tells me that the parallel slope is also going to be 2. So I'm going to, again, I have this point, let's see up here. So I'm going to start by writing it out in point-slope form. So y minus, and my y1 was -3, equals my slope, which is 2, times x minus my x1, which was 2. So this is actually y plus 3 equals 2x minus 4. And again, if you wanted to put it into slope-intercept form, bring that 3 over. Or maybe you want to put it in standard form. So then the 2x needs to come over here, The 3 can go over there. Either way works. This equation is also good. So if I wanted it in slope-intercept form, this would actually be, and if I wanted it in standard form, so this equation works, and if I want it in standard form, I'll bring the x and the y on one side. Actually, I think I'll bring the y over here so I don't end up with a negative x, and then I'll bring the 4 over here. So I'll end up with 7 equals 2x minus y. All 3 of those are correct. Okay, so be careful with, whatever your book says or whatever the test says, it's going to say to put it in a specific form. Okay, so mess around with that a bit. Let's talk about linear inequalities in 2 variables. So it's probably been a little while since you've seen this. Let's go with an example. So what if I gave you negative 3x plus 6y is less than or equal to, let's go with, how about 12? Okay. So let's review linear inequalities in 2 variables. And I'm going to give you an example. For x minus 2y is less than or equal to 8. So an inequality sign is in this, and that's why we call this a linear inequality. Let me remind you that this is less than, and let's go less than, and this is less than or equal to. Okay, and vice versa, right? This is greater than and greater than or equal to. So when you graph these, the less than and the greater than, so the less than or the greater than, those are going to be dotted lines. However, the less than or equal to or the greater than or equal to are going to be solid lines. So the only other thing I need you to remember or to recall back from Algebra 1 is that any time that you do operations with inequalities, if you multiply or divide both sides by a negative, you need to flip the sign. So let me just give you an example. Let's say we wanted to solve this for y. Okay, so we're going to subtract 4x from both sides. And then I'm going to divide by negative 2. So I've got y, and this, I'm going to skip this for a second. This becomes negative, oops, that becomes positive 2x, sorry. 2x minus 4. Now because I divided both sides by a negative, I need to flip this sign. Okay? So the key here is that if you multiply or divide by a negative, you need to flip the sign. I guess I can go over one more thing with you guys while I'm talking about flipping the sign. Realizing that if I write this, or if I write this, that's saying the same thing. Here, x is the bigger number, right? And when I used to teach Algebra 1, I'd always say, the alligator eats the bigger number. Okay, so alligator is eating the bigger number. Okay, Same thing here. X is still the bigger number, right? Alligator's eating it. So this is still, I can still read this as X is greater than 5, or I can read it as 5 is less than X. Okay, so you just have to remember that, I guess, alligator eats the bigger number. Okay. All right, moving on to example 3. I think I had too much fun with that. We're going to graph this. So basically, here's the difference between this and graphing an actual equation. In this, there are going to be many, many solutions that will make this true. So there are many answers. So this is where you actually shade a region of your coordinate plane. Okay? So this looks a lot like the one that we had above. The only difference is that the sign is flipped. I'm going to go ahead and solve it for y so that I can graph it. It's back to school night, and there's a lot of stuff happening in the hallway, so sorry about all that noise. Okay, and we're going to divide everything by -2. So that means I need to flip my sign. Y is less than or equal to, okay, and then this becomes 2x minus 4. All right, so I'm going to go ahead and I'm going to graph this, starting with my y-intercept, -4. Okay, and then from there I'm going to use my slope to get my next point. Go up 2 over 1. Okay, now before I draw my line, I need to make sure that I get the right kind of line. So this is a less than or equal to, which means that I am going to use a solid line, not a dotted line. So my solid line I'm going to draw. So there's our line. Now here's the thing. There are many, many, many solutions that will work here. So we have to figure out where these solutions are. Which points are our actual solutions? Okay, so there's a couple ways of doing this. One, I see this as y is less than or equal to this whole thing. So basically, if I go to my y-intercept, I want to shade below, right? I want to shade everywhere where my y value is less. So that's telling me right now that I should be shading down here. Well, let's double check that. Let's pick a point that would be in this region, and let's see if it truly does satisfy this inequality. So how about if I choose the point, let's see, 2, -1. So I'm going to try 2, -1. That is a point that I think is in the solution set. Let me just double check that. So I do that by basically plugging in my x and my y. So -1 is less than or equal to 2 times 2 minus 4. So -1 is less than or equal to, well, that's 4 minus 4, so that's 0. Is this a true statement? Is -1 less than or equal to 0? It is, which tells me that this is a solution. And that point was right here. So I know that I should be shading the side of my line that includes that solution. Again, I just picked an arbitrary point to test. I could have tested any other point. 0, 0 is always an easy one to test. Let's just try that and let's see if it works. So going back to here, let me pick the point 0, 0, and let's see if that works. We know that 2, -1 worked. Let's try 0, 0. So I plug that in. Is that true? 0 less than or equal to -4? That is not true. So I should not have this point in my solution set. So that tells me that I should not be shading here. I should not be shading where 0, 0 is. But I should be shading where 2, -1 is. So I'm going to shade this region of my graph.